presented it in a way that makes sense to us as human beings in the decimal code system. You've all probably seen this before. If you have a device connected now to the conference network or the hotel network, then your device probably has a similar IP address which it uses to connect to the internet. And basically this is what this is. It's called an IP version for address, IPv4 for short. It was initially deployed in 1983. The stream of zeros and ones is 32 bits. That gives us 4.2 billion unique and different addresses that can actually be used. Now this IPv4 addresses, or IP for short, are still the most commonly used version. Like I said, if you have a device now connected, you definitely have an IP address on it, and it's most probably an IPv4 address. Going more in details into these internet number resources, these internet number resources have to be unique. And the uniqueness comes from the fact that if you have two devices on the network that have the exact same address, your device will not know which one it can actually talk to, which one it actually means to talk to, which one it would be sending it to, and it will be stopped. Devices are dumb. They're not like human beings where they can distinguish there are two people having the same name. If there are two devices on the same network that have the same IP address, then it will just not send it to anyone. So, and as we just mentioned, the maximum number of IPv4 addresses are around 4.2 billion. So that's already a cap right there. There used to be just one person. His name was Jean Postel. You see him in the picture here. You probably heard his name throughout the sessions that you've had. That was responsible for managing that system, for the distribution of IP addresses. Basically, if you would need IP addresses to get connected to the internet, you would go talk to that one guy, and he literally would walk around with a notebook and write in it that he has actually issued these resources, these IP addresses, to that person or organization or university or whatever other entity was interested in being connected to this internet experiment at the time. Now that model did not really scale as the internet started to grow and be widely deployed globally. There needed to be a better, more efficient way of keeping track of those numbers. Like I said, because if people started using the same numbers, then packets wouldn't know where to go, and there had to be a system that registered who was using which IP address, at least blocks, at any particular time. So that one person got replaced with a function called the IANA function. Think of the IANA function as the main reservoir of all the unallocated and unused internet number resources, right? So they collected everything that Jean Postel had not given out, and they put that in that main reservoir. And basically, the concept was there would be these regional organizations, RIRs, regional internet registries, that would register on a regional level the usage of these IP addresses. And these internet registries would be responsible of then distributing and allocating these resources to the ISPs and end sites in their service region. So to take a quick example, if today an ISP in Turkey wanted to get internet number resources, IP addresses to connect, or a university wanted IP addresses to connect, or an end site as a factory or any other establishment that wants to have its own internet number resource, it will go to its regional internet registry. In this case, it will be the VIPE NCC. We'll talk about that in a second, and request the resources from it. And when the VIPE NCC runs out of IP addresses to give out, or at least they hit a a certain number of IP addresses. Then they go back to the IANA function and ask for more bigger blocks. And then they would chop those blocks up and start distributing them to their members as well. And that's, in a nutshell, how the Internet Number Resource Management system works. Now, as we've seen in these slides, there are 5 of these organizations, each one roughly in charge of a continental-size service region. These organizations in alphabetical order are AFRINEC for the African continents, APNIC for the Asia-Pacific region, AREN for the North American region, LACNIC for the Latin American and Caribbean service region, and RIPE-NCC, which is the RIR, the Regional Internet Registry, responsible for distributing of Internet number resources in Europe, Middle East, and parts of Central Asia. Now, this is the current model that is there. It wasn't always like that. There are some RIRs that came later in the game, and we will talk a little bit about how they were developed. So, for example, LACNIC was not one of the first RIRs to be established. In fact, both North America and Latin America and the Caribbean region were all served by one RIR, which was AREN. However, the local community in the Latin American and Caribbean service region felt that they couldn't keep up with the requirements and the level of development that was in North America, because the internet started there, so some of the ISPs and some of the internet penetration was a lot higher than it was in some of the countries in the Latin American and Caribbean parts. So they felt that they wanted to have an RIR that could better serve their own particular needs at a rate that would help them grow their networks better. Same would be said about the African region, or the AFRINEC RIR, where basically Africa was served at one point by 3 different RIRs, which were AREN, RIPE-NCC, and APNIC. Again, the African community felt that they wanted to find a way that they could establish their own RIR through the policy process that we're going to be talking about in a second, and come up with an RIR that can better cater for their own needs within their own service region. And that's basically how we ended up with these 5 organizations. As we see in the slide now, we're going to move a little bit more, and even from the discussion you can tell, we're moving a little bit more into the bottom-up community-driven bits. Basically, these RIRs, they are not decision-making bodies. They don't take positions. They do not lobby for certain technologies or certain global or national positions. They basically are in charge of distributing the IP addresses and the internet number resources throughout their service region, keeping accurate records of them, and they comply with the policies that are put from the community, that are built from the bottom up. It's not that the organization says, for example, this is the way we think would be best to serve the region, and this is the policies that we're going to apply. That's not how the RIR system works. In fact, well, the way it actually works is through something called the policy development process. And I'll be focusing a little bit about the RIPE community and the RIPE-NCC and the RIPE policy development, since we are in the RIPE region with this meeting. So basically, the RIPE community, which consists of basically everybody in this room now, and anybody that has a stake in the internet in the RIPE service region. So whether you live there, whether you have business there, whether you own an ISP, whether you do research, anybody that has an interest in the welfare of the internet in the RIPE service region and wants to contribute towards better internet number resource management distribution and policies, they can actually partake in this and be part of the they are part of the right community, but they can partake in the policy development process. So the right community develops these policies through a process where they go through mailing lists where they actually start putting their ideas together, start debating certain ideas, certain proposals that they put forward in trying to figure out a better way to distribute the resources. They meet during the RIPE meetings. There are 2 RIPE meetings a year where they meet face to face and continue the discussion, but most of the discussion actually happens on the mailing list. So if you have not been to a RIPE meeting, that doesn't mean that you're excluded from the discussions. In fact, all the work actually has to happen through the mailing list, and the face to face meetings, they just help facilitate and move the conversation forward a bit. Now, this happens so that everybody could be included, right? And that's a big important thing. Everybody has to feel that they are part of this because they are, and all these policies affect them in one way or another. So there has to be a way for them to actually voice their opinions, discuss and see what's the best way forward, or why certain policies were put in place at a particular time, and is it relevant to actually change these policies or review them now, which has happened more than once. The mailing lists are publicly archived. You can go to the MCC's website. You can see all the archives of the mailing list of all the different working groups, not just the policy one, and see how the conversation has moved over time. The minutes of the sessions at the RIPE meetings are also publicly archived, and all the information is there. This is all for transparency and record-keeping purposes. And all the policies are formally documented and published and made available on the website as well. And in case a policy comes up that obsoletes another policy, then you can actually also, by doing a few clicks, follow what has actually changed and what actually substituted what. Now, the reason why I'm mentioning this and talking about this in particular is if we take a look at the past 2 years with the policy development, we can go further and it would still be the same picture. But if we just take the past 2 years here, you can see that this is a distribution of which countries have had more people participating on the mailing list. And as you can see, some are doing more than others, but it's very clear that, at least from the Middle East perspective, there isn't that much. I think there were 2 contributions in 2006 from Turkey. I think there were 5 or 6 from Iran, and that was it. There wasn't anything more from the Middle East. Out of 172 different people participating from 30 different countries on that list. So that basically means that the entire Middle East region is not active, is missing out on voicing their opinions and voicing what they see might be a best way of distributing these resources. If we look at 2017, the trend kind of continues. Actually, in fact, there was no participation from Turkey. There were a couple from Iran, and that is it. So basically, that is a wasted opportunity for this part of the world to actually partake in an open system that is easy to use because it's basically email. You don't need to travel, so the excuse that travel budgets and visas don't really apply here. And even if you still want to contribute, not just via the email and the mailing list, you can also do that through remote participation at the RIPE meetings. Everything has remote participation available, and everything is properly archived, like I mentioned. Now, this is important for a reason as well. Now, one of the things that the RIPE community felt it wanted to do was to spike a little bit more interest from the Middle East in partaking and participating in this process. So we're actually bringing the right meeting into the Middle East. It's coming into Dubai later this year, in October, and we encourage everybody to try to travel to Dubai, but at least if you cannot travel, then at least take part of the conversations on the mailing list. Try to participate remotely, because this is basically the best way you can take advantage of being part of this system. Anyways, going back to the slide that we mentioned, that we will be focusing on a bit, we talked about what a regional internet registry is and how the system kind of works. We talked about the bottom-up community-driven bit. Now we're going to talk about the number resource management model, what that actually means. So, internet number resources, as we've kind of covered, are basically the addresses that are used online, the numbers that are used online to know where things are, so that devices understand and know where these things are. And they consist of IPv4, we covered that already. There's IPv6, we're going to talk about this in a second. And there's also something called autonomous system numbers, AS numbers. We're going to be dealing with each one of these in more detail as we go now. So basically, when we talk about the internet number resources, we already mentioned with IPv4, this is how it looks. We already know this. We know how the IP address looks. It's been in use now since '83. And you probably all have heard by now, there's something called the IPv4 depletion or IPv4 runout, and it's simple because we agreed that these IP addresses have to be unique, and we agreed there's a cap, a maximum number of 4.2 billion addresses, and also not all of them can actually be in use for different technical reasons. But if we look now at the number of people online, then we've actually, just by looking at the number of people, then that number, the 4.2 billion, is not a big number at all now. And if you look at every individual person, they probably have, you now probably have more than one device capable of connecting to the internet. You probably have a laptop, your phone, and back home you have a PlayStation, you have a couple things that you connect to your home internet. And that doesn't even take into consideration stuff like domain names that need IP addresses, stuff like devices that are at the ISPs that are using these IP addresses to route the traffic around. So you quickly figure out that the 4.2 billion are not suffice for the growth of the internet the way it has actually grown. And that's where you start hearing about something called IPv4 depletion. And basically what IPv4 depletion is, so now we know this model, right? The IANA, the main reservoir, the 5 RIRs, the 5 regional internet registries that distribute and allocate these IP addresses to the ISPs and sites in the different countries and their different service regions. That now is very clear. What happened was that IANA, the main reservoir of IP address resources, ran out. It doesn't now have any more of these big continuous blocks that we call /A's, roughly 16 million IP addresses. It doesn't have more of these to allocate to the RIRs once they run out. This happened in February 2011. And since that moment, now each and every one of these RIRs were left to distribute their resources based on the policies that their community came up with, right? And based on the consumption rates, they started running out one by one as well. So first one to run out was APNIC, the Asia Pacific one. They have huge communities there, the Chinese community, the Indian community, a lot of development happening there in that part of the world. And based on the policies that they had there, they also had something which was preserving addresses. So they were the first ones to run out. They ran out in the same year in 2011. 2012, the Ripen CC ran out, and basically by ran out, they reached a threshold that the community agreed on. I'm going to talk about this more in a second. That they said, once we hit that threshold, we need to take action. So they don't have any more, again, big continuous blocks that they can give out of those /8s. So if once an RIR hits, again, this is based on every region's policy, but in general, once they hit a certain slice, a lot of them have that as a /8, then they do not distribute the way they used to, which was basically if you can justify the resources, you get them. So if there is an ISP, for example, that could have justified 30 million IP addresses before run out, it would have got the 30 million IP addresses. After run out, then it's based on what each RIR system has as policies there built by the community. So, like we said, a PNIC ran out first, Ripen CC, LACNIC, AREN, and recently AfriNIC as well. AfriNIC was one that kind of had a little bit more resources after everybody else hit their final threshold, simply because the consumption rate in Africa was a lot slower than it is in the rest of the world. It's not that they had more resources. In fact, Africa has the least number of IP addresses if you look at the 5 service regions. However, because the consumption rate wasn't as high, that's what kind of left them with a little bit more resources to linger behind when everybody else ran out. And that's why you would find, for example, looking at the Arabic-speaking countries, the ones in the Ripen CC service region.
So does anybody have any questions? Yeah. You want to ask? Okay, so actually I think I'll need to connect him via Skype. I'll just share the screen with him.
Hello?
Yeah, hi Hisham, can you hear us?
Hello?
Can you hear us, Hisham? Okay, it's really quiet. We need some help.
Can you hear me?
So this is the video actually. If anybody has any questions, we can ask Hisham a quick couple of questions before we proceed. So the video is halfway through. That's muted.
Hi Hisham, this is Kadir. Can you hear us? Hisham.
Yes, hello?
Can you hear us?
Barely, but yes, now I can hear you.
This is Kadir from Datiyar. How are you?
I'm good. Yourself?
Good. So it means that you understand me. So let's go.
Okay, Hisham, so we are actually halfway through and we asked the participants if they had any questions. So far nobody has any questions, so we'll continue with the video and you are connected.
I'm sorry, I can barely hear you. I heard that they're halfway through the video. I've been following you through the stream, but can you speak up a bit?
Yeah, so is this any better?
It's a little bit better.
Yeah, okay, so we'll continue the video. We're halfway through and we'll continue through the video and you're connected online now, okay?
Okay, perfect. I'm here. Thank you. It run out for at least 5 years now, while as the ones in North Africa still were able to request some resources from Afrinet until recently. So diving in a little bit more into the IPv4 depletion and what happened. So at the right region, basically on the 14th of September 2012, the RIPE NCC began allocating from its final /8, which is the threshold that the community puts for the justification system. So as we mentioned, before that date, if you had put in a large request to obtain IP addresses and you could justify the use, because the RIRs were the custodians of the space that needed to make sure that that space was not being over distributed. So they would have a little bit of back and forth with some of the ISPs, and if anybody has gone through this process with their RIR, they would know that they would ask for stuff like their designs, their number of customers that they're serving, the distributions of their networks, the different POPs, and that way they could help them figure out the exact number of IP addresses that they need. But once they could justify those numbers of IP addresses, no matter how big they could actually apply for them and take them. But after this date, the RIPE community felt that they wanted to safeguard the growth of the internet. They wanted to put a cap on the number of IP addresses that the NCC members could request, because that way it allows for more and more members to pop up in parts of the region that were not yet ready at the time to make the larger requests before final /8. And that cap was set at a /22, which is roughly 1,024 IP addresses. So since that date, in September 2012, any member that would request resources, whether existing or new member, could only get from the NCC 1,000 IP addresses. Since we're focusing on the Middle East a bit, so I came up with a chart that tries to illustrate the population, the number of internet users, and the number of IP addresses in this part of the world. And if you take a look here, it's divided into 4 subregions: the Gulf countries, the Levant countries, Turkey and Iran. Because Turkey and Iran have huge communities there, population-wise, and in terms of resources that make that distinction very visible. So if you look at them in terms of population, internet users, you can see that roughly half of the population is connected to the internet. So there's still huge room for growth for the service providers in these parts of the world to continue to need to grow to serve the rest of the community that is not served currently. But if you look at the number of IP addresses, then you find that it's currently 1/3 of the number of internet users, and it's much, much lower than it is for the potential growth of the market, which is the entire population set. And again, we mentioned before that each one individual person doesn't necessarily only have one IP address. People have multiple devices. IP addresses are used for the domain names, for all the lovely devices that are now connected to the internet. So it's clear that IPv4 isn't really scaling to meet the demands in the Middle East at least. So post IPv4 depletion, right? What ways are there to get more addresses into the pool that we've seen there that allows to continue the growth of the internet? Because the internet is going to continue to grow. New services and technologies are going to be rolled out. We see this every day. We expect more and more of this to happen, while runout has happened in most parts of the world at least a couple of years ago, if not more. So in the NCC service region, you either become a member, you either do some IPv4 transfers or go to the brokers, the gray markets there. We're going to talk about that in a second. You either use technologies something like carrier grade NATs, or use IPv6. And we're going to be talking about these very quickly and very briefly just to give you a better understanding of them. So if we look at the first option, which is becoming a member of the NCC, we said that the community had said that each new member starting runout, each member will be allowed to have a one-time /22 1024 IP addresses. If you look from runout, which is represented by that dot, you can see that roughly since then, the number of members of the NCC region, or the right region, has actually doubled. These are more and more people that are trying to request the resources. First of all, because obviously run out and they require the resources, but more also because when we've been seeing a trend there where more of these end sites, whether they're banks, whether they're universities, whether they are enterprises, they want to get their own resources so that they have a little bit more say on their routing, on stuff like multi-homing, stuff like getting load balancing for more than one service provider, and others as well. We currently have over 16,000 members in 75 countries in the service region here. And if we take a look at the breakdown of these countries, you can see that most of the membership base is based in Europe, whether Central Europe or the Southeast European part, as you can see. That's a big chunk of the membership base. Then you can see to the right of the chart there is Central Asia and Caucasus members and representing the total number of NCC members, and then at the bottom there's the Middle East. But there's a clear, if you look at that, even though the numbers compared to the other regions are not that high, but you can obviously see a clear growth. I think the numbers doubled since runout as well, and there's a clear growth there. That means there's a need for more and more resources in this part of the world, and we've been seeing this more and more. Now another option that we mentioned to get resources and IP addresses in this part of the world is IPv4 transfers and brokers. So some members may decide that they want to use a broker to seek new addresses, whether to transfer the resources that they have for a fee or not for a fee, or they are actually seeking to get some of these resources. We at the NCC, we don't get involved with the process itself, but what we do get, the agreement and how much the IP address goes for, if I'm not mistaken, the current rates are anywhere between $10 to $15 per IP address, but it's mostly around 10. It depends on how big the block is and how much availability is there at any given particular time. The NCC gets involved in the process just to make sure that the records are kept up to date, so that it doesn't reflect that one organization holds the resources while in fact they've already transferred it to another resource. And that's why we try to keep on top of this and let our members know that when any of these transfers happen, they have to properly record them in the databases. There's a URL here on the slide that lists some of the brokers, talks a little bit more about how this process happens. I have a couple slides that I borrowed from a friend of mine. He actually owns a brokerage company, and he presented at MENOG on some of the statistics that he saw from resources moving from one RIR to another. The NCC publishes all the transfers that happen in the NCC region, but because the brokers tend to look at how much resources go back and forth through the different service regions. So I thought that the slides he presented were interesting and I wanted to share them with you. So in 2015, you can see that from the NCC to the APNIC region, there aren't any resources that were transferred back and forth between those two regions. And in fact, the NCC didn't transfer any resources out of the region. You can see a lot of resources being pushed around within the region itself, but nothing leaving the region. And in fact, there were only some resources that came in from AREN, the North American RIR. There were some resources that were being transferred back and forth between AREN and EPINIC, but yeah, that's what was recorded in 2015. In 2016, you can see that now there's still huge trends of resources being pushed back and forth within the service region itself, and sometimes these transfers aren't necessarily them leaving hand from one organization to another through a brokerage or selling them. It could be an organization that was bought and due to the merger and acquisition, they transferred their resources to the mother company or for other reasons. But the interesting bits are the resources that moved from one RIR to another. Now, the reason why it only shows these three RIRs is because these are the ones with the inter-RIR transfer policy that the community came up with. So, for example, in the AFRINEC community, they felt that they didn't want an inter-RIR transfer policy because they felt that the resources that they had was so little already that if they would allow people to transfer their resources, they may end up losing some of the resources, especially with the low consumption rates that they had in Africa. And again, that's a decision that the community makes, and the RIRs just follow what policies that the community put in place. Another thing that is currently widely deployed, and especially in LTE and mobile networks, is something called CGN, Carrier Grade NAT. NAT basically means that they're using virtual IP addresses, not public IP addresses. So imagine the room that you're in now. Let's say there are 30 people in the room. I can't count you, I'm sorry, I'm not in the room. But let's say there's 30 people in the room. So they require 30 unique IP addresses to be able to connect to the internet, right? Now, a couple people came up with a way that you can actually say, okay, instead of giving everybody an IP address, let's give the whole room one IP address and let them share. So basically, everybody still needs an IP address, but these would be virtual IP addresses that mean nothing on the internet itself. But as the packets start leaving the conference center network, they get replaced with the real IP address and they start sharing that. Now, already you can start imagining limitations in the number of people that can actually share an IP address. What if I'm doing a lot of traffic? What if I require more ports and others? And these are some of the drawbacks that are there with using CGN. It just doesn't scale. It helps for a while. It was invented as a temporary technology, but as more and more of these technologies get rolled out, like LTE and more devices are connected, you end up facing again a scalability issue. And in fact, a lot of the law enforcement agencies are talking against CGN now because basically they feel that it hinders their investigation when they start looking into something. Again, the example that we just gave of 30 people in a classroom, or if they see something malicious happening out of the classroom, they want a way to find out who was actually doing so. They don't want to look into the 30 people that were sharing the IP address at any given time. And as NAT and CGN scales and they allow more and more people to connect and share the IP address, that makes the law enforcement agencies' life a lot more harder in finding the actual perpetrator of a certain cybercrime. There's a paper out there, the URL is there, feel free to read up more on this if you're interested, and share it, please, with your law enforcement agencies and certain communities within your countries as well. The final option is IPv6. We've mentioned IPv6 before when we talked about the internet number resources. So basically what happened was IPv6, similar to IPv4, uses binary code, but it's instead of being 32 bits, it's 128 bits. So you can see how big the representation is. And in order to shorten it down, instead of using decimal, that would make it still relatively large, they started using hexa, which is a 16 base numbering system. So that's why you see stuff like B and D all the way up to F in there that represent the numbers from 10 to 15. So to compare them really quickly between IPv4 and IPv6, IPv6 basically does the same exact function as IPv4. Don't listen to anybody that says IPv6 is better than IPv4. It was designed to do the exact same thing as IPv4, which is tell people what the address is of this particular device and what the address of where it wants to go to is. There's just a lot more of them. There's 340 trillion addresses versus the 4.2 billion that were there with IPv4. And the reason why IPv6 is so crucial is because of a buzzword that I'm sure everybody has heard, which is the Internet of Things, right? Smart cities, interconnecting, smart mobility, smart health, devices that are talking to each other. They all require to connect over the internet. And if once they hit the internet, no matter what numbering scheme they use, they could actually use more than one way a numbering scheme to communicate amongst themselves. But once they actually hit the internet, they have to use IP. And if they use IP while IPv4 has run out, well, it just won't scale anymore. And that's why IPv6 is crucial for the scalability and the interoperability of all these devices talking to each other and all these different systems talking to each other. For those that argue that IPv6 hasn't really taken off, well, these are charts from Google that show that at least let's say roughly 20% of the traffic that Google sees globally comes over native IPv6 traffic. Right, these are recent graphs. If you look at the global distribution of them, you can see that the North America in particular, Brazil and parts of the LACNIC community, the European bits, you can see a lot of green there that represents, the darker the green is, the more IPv6 that users that are talking to Google from these parts of the world. There's still some work needed, especially in Africa, but as you can see globally, IPv6 is happening there. Now, when we're talking about the internet number resources, we also talked about autonomous system numbers. Basically, these are numbers that represent the network that you can use you need when you're using stuff like BGP to do multi-homing, basically having more than one provider, doing traffic shaping, selecting where your package actually end up going. But in the simplest terms, it distinguishes and separates you from your service provider. So if you don't have an ASN, you would be seen as part of the network of your ISP. But if you do have an ASN, then people will understand that this is you, and then you go to your upstream provider, in simplest terms. So when you connect to the internet, so a network, it could be the hotel network, it could be a ISP, it could be a university. They have an ASN that represent their network, right? And for them to connect to the internet, they have to connect to another network that's already connected to the internet, right? So let's say we're talking about the conference venue. It has its own ASN, it has its own network. It needs to connect to a service provider that's already connected to the internet, right? It usually does this for a fee. Now sometimes it may use more than one service provider for redundancy. They call that multi-homing. And they end up buying the services and doing their traffic shaping and sending their packets back and forth there. Now these upstreams, they could be within the same country or they could be out of the country, right? So for example, even the larger ISPs within the country, they still need to connect to even larger global ISPs to be connected to the internet afterwards. So when two ISPs are talking to each other, two networks are talking to each other, if they don't have any way of talking locally within the country, if they're both getting from upstreams that are out of the country, then even the domestic local traffic that was not intended to leave the country actually leaves because there's no interconnection within the country. Now there's an easy fix for that, which is something called an exchange point. I'm happy to expand on that more in the Q&A, but this is just roughly a quick understanding of how these ASNs talk to each other and how by building a critical infrastructure like exchange points and doing peering and interconnection on a country level, that minimizes the cost and helps with stuff like latencies, because you don't have to send your traffic out of the country, it all stays within the country, helps with stuff like security and others. The last thing I'm going to be mentioning really quickly before I open it up for Q&A is there is a forum for network operators called the Middle East Network Operator Group, or MENOG for short. I've put the URL here for the website. Please feel free to visit it. MENOG is an event that is basically has two parts to it. There is a meeting that's done once a year. That has all the invites all the players from the region and those that have globally that have vested interest in the region. They come, so you have the CDNs, the content providers, the Googles, the Facebooks, the Akamais of the world. They all come and attend that. The ISPs from Etisalat to Turk Telecom to Ojero to Omantel, all the service providers within the region, they attend, the cable providers, the academic communities, they all attend there and start talking about issues related to the internet in the Middle East particularly. There's also the road shows, which basically are trainings that are coordinated through MENOG that travel to every particular country in the 14 countries in the Middle East and deliver different workshops, whether on IPv6, whether on DNS, or whether on routing and peering and building exchange points. There's more information on the website there. In 2017, earlier this year, we've had the 10-year anniversary of MENOG. There's an article that is published on what we've actually learned on how to build the NOGs and how to continue better servicing this part of the world. We're working with a couple countries on building their national logs as well and helping them start them up. So for example, we've worked with local community in Iran in building IR nog. We collaborated with Afrinet on helping start up SDNOG in Sudan, even though it's not technically in the RIPE service region. But because they are big contributors to the MENOG events, and we wanted to help encourage them and have good examples in this part of the world. We're also talking to few other countries on doing the same as well. And if you're interested, please ping me. This is my email address, and now I'm happy to take Q&A.
Hello. Hello, Hisham, once again.
Yes, hello, first.
So we have concluded the video, and the floor is now open for questions. So we'll be taking in questions. Any questions for Hisham? Yes, please, Susan.
Can you hear me? Sorry.
Yes, definitely. I'll do that.
Talked about transfer of IP blocks. Are these transfers made on, cost basis, or are they sold like property? Just one question. Another is about NIRs,
Okay.
National Internet Registries. This wasn't on the presentation, but according to RIPE and CC's policies, are such structures allowed to be established in
Okay.
countries? And if yes or if no, I don't know. Does Hisham think that these structures are useful in terms of supporting the development of internet in that country?
Okay.
Or what are the
Okay.
Thank you.
So Hisham, we have a question from Sazan Yeshid. She's from the BTK, from the regulator here, and her first question is about the transfers. So she asks if when the transfer happens, is it on a lease basis or is it on a property basis, where the person who actually gets these IPv4 addresses through these brokers owns them or not?
First of all, thank you for the question, and thank you for listening through the video. I know how challenging it is when a presenter is remote. To answer the question, basically what happened, like I said in the slides, the NCC doesn't get involved much in the agreement, so they could agree to transfer the resources for a certain period and then transfer them back based on what they agreed on in terms of fees and in the contractual agreement itself. But what we've seen is basically the transfers are happen where one entity that is the rightful user of these resources just hands them over to another entity as well. So we've seen a lot of transfers, for example, happen out of Romania Telecom that have a lot of IPv4 resources, and for whatever economic reasons that they have in the country, they felt that this is a way that they can make good money for the incumbent, and they started shipping out large blocks of those resources to other countries that are now the rightful owners of those resources. There are other countries, I know, for example, Spain, for example, they actually use this model as a way to cover the expense of deploying IPv6, where they would transfer those resources, the IPv4 resources, and the money that they would get, they would invest that into doing IPv6 deployments.
So
that answers the question.
So to confirm, it becomes proprietary, right? So they own the IP addresses once they buy it from a broker.
So nobody actually owns the resources. They have the right to use the resources, because the way the system works is that technically when you become a member, you have the right to use these resources, right, that have been assigned to you and are in the right database. Once you decide not to become a member, once you don't need those resources, the idea is those resources go back to the RIR and they get put back in the pool, so that others may use that. However, because you are currently the rightful holder of these resources, you may elect to transfer that right to somebody else, like I said, whether for a fee or not. We've seen many cases where these transfers happen from like a mother company to one of its subsidiaries, for example. We've seen this, as I mentioned in the slides, where you find, for example, through mergers and acquisitions, you find that they want to consolidate all these resources into one membership of the holding company. So we've seen all these different examples.
Does that answer your first question? Okay, so Susan asks another question, and she's asking about NRIs. And she asks if you can give more information on that, and if you think it's a good approach, what's its pros, what's its cons?
Sure. There are a few NIRs out there. So just to expand on what an NIR is, it's a National Internet Register. And to give a little bit of historical background, so especially in the APNIC, the Asia Pacific region, there were some of these national internet registries, these NIRs, that predated the existence of APNIC. So, for example, Japan had a national internet registry. I know Korea has one. There are a few countries that have them that were even existing before APNIC was there. When APNIC started out, the community sat together and they said, well, we already have this process in place. There's no point of redoing it. But to clarify what an NIR does is it just makes sure that the registry is kept up to date. It's not like they get allocated big resources and then they distribute them nationally. What they only do is they coordinate and make sure on a national level that the databases are up to date. They make sure that people register what resources they're using in an effort to help out with the RIR. They do not get allocated big blocks. It's not like the system where IANA gives the RIRs and then the RIR would give a national internet registry and they would distribute the way they see fit. That's not how the NIR works. There are a few that came out after. Brazil, for example, has an NIR. India started an NIR. There are a few regions that do have NIRs. There aren't any in the RIPE region. There aren't any in the AFRINEC region. There aren't any in the Airborne region. It just comes back to whether the community sees there's need to do this or not.
Does that answer your question? Any further questions? Yes, Mona.
I read somewhere that shifting from IPv4 to IPv6 needs some requirements. Like, I don't know, correct me if I'm wrong, that it needs some special devices, and the ISPs in some countries, they don't want to shift to IPv6. So I want to know the barriers that faces shifting to IPv6 and why there are some opposition from ISPs, something like that. I'm not sure how they work.
Okay, so Hisham, we have a question from Muna and she's asking about IPv6. So she says that she heard that IPv6 needs special devices, needs special requirements, and then she asks, why do ISPs not move to IPv6 and what are the obstacles that are hindering them to move to that?
Okay, yeah, that's actually a great question. The thing is that IPv6 does, like any technology, does require certain features and devices to be able to do certain things. And most devices today support them and have them. However, if you own a device that is, let's say, 10 years old, then it may or may not have everything it needs to support IPv6. And that's where some of the financial issues that you hear ISPs talking about. For example, a lot of the CPEs, the home modems that are deployed at people's homes now, a lot of them are at least, let's say, 5 to 6 years old. People don't replace them that often. If they're that old and that cheap, because we usually go for the cheaper modems, then they may not be capable of doing what needs to be done for IPv6. However, a lot of the ISPs, especially the ones that are actively doing IPv6, it's easy for you through your purchasing cycles over time to get rid of the devices that do not support IPv6 and only support IPv4 and start doing the stuff that does support IPv6. And today, especially with mobile internet, it's making things a lot easier. All the 4G equipment, so LTE, which is the acronym of 4G, it was built with IPv6 in mind, again, to scale with the amount of IP addresses it requires. So anything that supports 4G supports IPv6. That's an easy connection to make. So all the operators that are doing mobile services over 4G can do IPv6. Or most of the handsets that you're carrying that can do 4G also can do so. It's just the major issue is usually
the home modem CPEs that if you think back when is the last time you replaced it, you'll probably find you haven't replaced it for at least 5 years, I'm guessing.
Any other questions? Yes.
So we said that the IPv4 runout process began several years ago, but IPv6 was actually invented in 1998. So before this process began, was IPv6 deployment began in any of the development countries or not? This is the first question. And the second question, what's the long-term plan for the deployment of IPv6 alongside IPv4? Is it better to use them alongside, or is it better to just move to one approach, only the use of IPv6?
So we have two questions from Mujibullah Shams, and I'll ask the first question. So his first question is about IPv6 again. So he says that IPv6 was invented in 1998, while IPv4 depletion started somewhere after probably 2010. So he asks if there were any successful IPv6 deployment before the IPv4 depletion started.
There were, however, it's part of human nature not to change things if they're working, right? People tend to stay to what they feel comfortable with. So there were these deployments, of course, before run out. However, I think totally it was less than of anybody's registered traffic. But with and there was a reason for that as well. So in runout was 2011, right? And until 2011, there was a big debate: who needs to move first? Is it the content providers, the Googles, the Facebooks of the world? They will come back and say, well, the ISPs are not ready, and we don't get any traffic over IPv6. Why do we need to do that? The ISPs would argue the other side of the equation, which is if there's no content, then people don't want to reach anything over IPv6. Why do we need to deploy that? And that debate happened all the way till 2011 when IPv4 runout happened. 2000. So since runout in 2011, the content providers, they all came together and agreed and said, okay, somebody needs to take the first step, and let's do that. And that's what they did. So in 2012. There was something called IPv6 Day. It was, I think, the 8th of June 2012, where all of the content providers turned on IPv6 for one day. And the idea was, because if something goes wrong, it goes wrong for everybody, right? Some of them were happy with what they found and left it on. So YouTube was left on over IPv6. And by left on IPv6 means you can reach it. When you type in Google, you can reach it both over IPv4 and IPv6, the same. You don't need to type in IPv6.google, for example. And a year after that, everybody, or the content providers, they all agreed to do IPv6 launch, where they turned it on and they just left it on. They were comfortable enough with that. Since that happened, encouraged more and more ISPs to do that, and then you saw the trend going up. And if you remember the Google map that you saw, then you would see definitely after 2012 the numbers were starting going up, because now there was real content over IPv6 that people wanted to reach.
Okay, so are you done? Yeah, yes, Hisham. So are you done?
Yes, I mean, I can expand on that for an extra minute and say there are some major providers like AT&T, for example, and T-Mobile in the US. These are mobile carriers that, because they have huge subscriber bases, I think T-Mobile has over 50 million mobile subscribers, that now they have all their mobile subscribers over an IPv6 only network, and that's why you see the US very dark green. Some of the cable companies like Comcast as well in the US are also doing IPv6. I'm giving US as an example, but you can say the same about Belgium, that actually has the highest percentage of IPv6 traffic worldwide. You can say the same about Orange Poland, There are a lot of different examples of that, where now the ISPs and mobile providers are moving more towards IPv6, and that's why the numbers are going up.
Okay, Hisham, Mujibullah also has another question on IPv6. So he says, is it advisable to deploy IPv6 and have IPv4 run in parallel, or is it advisable that you just use one technology at one point in time?
So is it advisable?
Sorry, Hisham. You were
IPv4, is that the question?
Can you repeat, please, because you were breaking?
Sorry, the question is it advisable to do IPv6 in parallel with IPv4? Was that the question?
Yes.
Yes. So, okay. So, as mentioned in the slides, still IPv4 is still the most widely used internet protocol all around the world, right? We reach a point in life where everybody, till that day happens, and it's not probably going to happen anytime soon. Both IPv4 and IPv6 need to cope. It's a transitional phase that any technology has gone through. You still have mobile providers today that do 4G and feature provision for them. So there are a few different transition mechanisms. We quickly let me go to before an IPv6 in parallel. This has its advantages and disadvantages. This is one of the most widely used models out there. There's another where you use something called translation, where basically, so dual stack is like being bilingual. The device can talk both IPv4 and IPv6 depending on who's talking back to it. There's another transition mechanism, which is translation, which is clear from its name. I only speak one language, which I IPv4 or IPv6. And locks in the middle that translates back and forth for me. That's similar to what NAT does, where it replaces before address and packet with an IPv6 packet and vice versa. The third option is something called tunneling, which is you basically establish like a tunnel where you can pass IPv6 packets through. They're limited. It depends on what the network is actually doing and trying to achieve. Yeah.
Okay, thank you, Hisham. So there are three techniques. So you have tunneling, you have dual stack where you run both IPv4 and IPv6, and then you have translation, and then you have tunneling. So each one of these technologies has its pros and cons. Any other questions? Yes, sir.
So in the beginning of the presentation, you mentioned that there is a lack of contribution from the Middle East. Like, what are the reasons behind that? Is it the responsibility of government to support its engineers, or of the businesses to support?
Okay, so we have a question from Yusra, and she says at the beginning of your presentation you mentioned that the contribution from the region in RIPE NCC's policy development process is quite shy. So what's the reasons behind that?
Somebody lost audio.
Okay. I'll ask him here. Yeah, Hisham, we can hear you. Can you hear us?
Okay. Yes, perfect. Yes, and I got the question in text. The question is, why is there low participation from the Middle East in the PDP process? That's also a very good question, and a question that I think most of the organizations, global organizations, tend to ask, and they ask the audience that. Because whether it's ICANN, whether it's the RIRs, whether it's ISOF, whether it's any of these organizations that tend to engage with the community, they do offer different ways of engagement, whether through mailing lists, whether through remote participation like I'm doing here now, and through other mechanisms. It just depends on how vested people are, let's say, in being part of that. And we've seen that very dominantly in parts like North America and the European parts, where they are very keen in participating in building the technology, in being part of it, having a say in it, having a say in what the policies are and how it's applied. However, unfortunately, from the Middle East perspective, and I've seen this also in Africa, where people are more consumers of the technology than they are shapers of it. And that's something that we're actively trying to change, and it is getting better over time. However, unless people feel that they actually do have something to say and contribute, which they do, you usually find people shy away from doing so. And we usually advise people, the first thing, the easiest thing you can do is subscribe to a mailing list. See some of the traffic that goes back and forth. You don't have to participate right away, but you would see that there are others like you that are still new to this, that are asking questions, and people that have been doing this for a long time, walk them through the process, explain to them why things are. There are a lot of really good ideas that come out of fresh eyes and fresh perspectives. And yeah, everybody's opinion is important. We do encourage as much participation as possible. Again, that's one of the reasons why both the right community and ICANN are bringing their meetings into the Middle East here to help spike that engagement.
Does that answer your question?
So my question is about the ISP. Are they going to be as useful as they are in case of IPv6? Now they're working in IPv4, and the countries that use that use internet security points in relation to the RIR. So which RIR is using the most internet security points?
So I really didn't get your question. So what was the first part of your question?
First part is the usage of ISP, IPv6, IPv4. Is it going to be for the same usefulness, or is it going to do some of this functionality in case of IPv6?
Get your question really.
The IPv6.
Let me explain the question. What Muhammad wants to say is, how is the IPv6 transition going to affect the use of internet exchange points, IXPs?
So is that your question? Okay. So we have a question from Muhammad, and he says, how would IPv6 benefit IXP operations? Would it change anything? Would it be the same?
Basically, IPv6 helps scale things. We in the RIPE region here, we've been living in a post IPv4 depletion for at least 5 years. And during these 5 years, 4G happened, LTE happened, IoT discussions started happening, and governments are getting more and more involved with eGov solutions and IoT solutions and smart city solutions. All that requires IP addresses. In the presentation, I've mentioned all the different ways of doing so, and we've experienced and seen operators that have gone through every single one of them. I can give an example from Saudi, for example. So Saudi, they a lot more members started showing up in Saudi, getting the results. Some of the more established operators that were there for a while, like SCC and the others, they went through the process of, okay, they got the final /32, they got 1,000 IP address. That didn't last long. So they ended up buying IPv4 addresses from the brokers and getting those resources. However, it ended up being a very expensive way of doing so. It just didn't scale anymore. I think reportedly both Iran and Saudi are the highest two countries in terms of IPv4 transfers from other countries, which you can guess come with a fee, and if you apply a $10 per IP address, just as to make an assumption, you can easily say that these two countries spent more than $50 million on obtaining IPv4 addresses. So the CGN, they tried that. CGN gets messy really quickly, for example, and like I said, Versakit, and it adds latency, it adds new boxes that not really belong on the network that can do the NAT, and again, scalability issues are there as well. So most of those that have went through the process, they all figure out that IPv6, even though there may be first initial investment in teaching people how to do IPv6, because it does require a little bit of a mindset shift. So there's a little bit of investment in training, which a lot of organizations do for free, including the NCC, and like I said, there are the MENOC roadshows and others. It does require to look into your network and see what supports IPv6 and what doesn't support IPv6, and the stuff that doesn't support IPv6 needs to be phased out. However, if you look at the long-term benefits of doing IPv6, it outweighs any initial cost that you may have at this point. And that's where most of the operators have figured that out. And I gave examples from Orange Poland to the US to the Belgium operators to even operators in Africa. There's for those familiar with sub-Saharan Africa, there's an operator called Liquid Telecom, which is the largest terrestrial cable in Africa. It goes through a bunch of different countries in East and South Africa. They're also rolling out IPv6 and doing a lot of IPv6 there. It just makes sense on the long term.
Answers your question?
Yes, it's only a technical question. I'd like to clarify what's /8/22/32.
So we have a question from Omar, and he's asking about what does /8 mean, what does /22 mean, what does /30 mean, and so on.
Sorry, Fat, is that for me? Because I can barely hear that.
Okay, sorry. So can you hear me better now?
A little bit better, yes. Go
Okay,
on.
so we have a question from Omar, and he says, can you explain what does /8 mean, or /8 mean, or maybe /22 or /30?
Yeah, sure. That's just technical jargon. You know, as Sakis, we like showing off with our acronyms and you know, our secret language. Basically is a way of saying a big block of continuous IP addresses. So a /8 would be roughly 16 million IP addresses. /22 would be 1,024 IP addresses. /24 would be 256 IP addresses. It's just a way of saying you have this continuous number from, let's say, 10.0.0.1, or .0 actually, to all the way to 10.0.0.255, which is a /24, and so on and so forth. Does that answer the question?
Yes, Hisham, thank you. One last question.
How NCC plan to encourage the implementation of IPv6
Okay.
what resources are available for training and facilitating creation of IPv6 based.
So we have a question from Khansa for you, Hisham, and she says, what are the activities that RIPE NCC are currently undertaking to encourage IPv6 deployment in your region of service? So she's asking about capacity building and any other initiatives.
Sorry, your voice keeps on fading down. The IPv6 or something like that?
Yeah, so what is RIPE NCC doing to encourage IPv6 deployment in your region of service, like training programs and other initiatives?
Yeah, okay. That's actually a very good question. There's a lot of things that the NCC does, and the other RIRs do as well. The easiest thing I can tell you is we organize trainings free for our members. So we make a point of trying to visit every country in the service region. We have 70-something countries, so it takes us a little while to circle back to countries. But at least I can tell you in the whether through the NCC, which the NCC partners with, that we have visited all, we go in with a training, we help everybody on that mindset of doing IPv6. One that recently launched is we work closely to plan a nation's deployment for a governmental network. A lot of countries now have something like federal networks or a e-government platform that spans across a large number of governmental entities that may or may not be that technical to actually do that deployment or do at least the planning, initial phase of planning. So the NCC does a lot of hand-holding there where it helps them to do so.
Okay, so let's wrap
which I just said is recently launched. We've also been doing this for years with our members and with the operators to do so as well. So basically, it comes down to doing a lot of awareness through sessions like what we're doing here now, doing a lot of training, doing a lot of hand-holding, getting that message across, because it's not just one stakeholder that has the key to do this, right? And for a long time, people were just talking to the technical community because they assume that the technical community, it's a technical issue, the technical community is the one that's valid. Everybody needs to be involved, government needs to be involved, the law enforcement agencies need to be involved because they have a stake in this as well. For example, there's a big gaming community, right? People like playing online games. There's also a big streaming community. Media and movies and stuff, but especially when it comes to latency sensitive applications like gaming, for example, if I click, for example, I want the response time to be immediate. Because if there's a delay, then somebody else on a better network that doesn't have delay can actually, shoot me and get me out of the game. This is one example of where latency comes in an issue, and stuff like CGN and NAT adds to that latency. And it becomes less of an ideal service for people to actually be able to deploy stuff like this. It comes back to us as well, like stuff like, for example, with your car now, where it gets updates from your operator on traffic and which road to take. Again, you don't want huge latencies there. And this is stuff that we maybe not everybody involved sees right away. The people that are developing the cars may not understand that higher latencies may come because the rigs are using NAT, and the operators may not understand that there are some of these latency sensitive issues. They comply with what they understand. And then no. So for example, when it comes to voice over IP, they don't do too much latency that would affect that. But now with IoT happening, and just through raising that awareness and bringing people together and discussing these issues through different forums, including like MNOG, the one I gave an example of, and the local NOGs that bring the community together. Through all these different initiatives and much more, we try to accomplish those. That's the question.
Answers your question? Okay. Okay, thank you so much, Hisham. So the session has concluded, and if anybody has any follow-up questions, we'll just ask them to send them by email to you. Thank you.